So today I'm going to give a demo of osteoporosis detection. So this disease is present mainly in the bones. So initially we have collected the data set of osteoporosis detection, and training is done through the neural network, and testing is done through the GI. So in this project we have collected the data set of normal one and diseased one. Based on it, we can predict whether the image is diseased one or not. So now we go for the code. So this is the training code. And this is the data set. This is the normal one. So you can see the normal data set, osteoporosis. Yes. So this is the data set we have collected. So these are the libraries we have imported. And this libraries we use for to load the files. And this is for to convert image into the other format. And this is used for to list all the files. And we have two folders, normal one and osteoporosis. And this is the dataset folder. And in this, we are loading the file. And after that, we are converting the each image into the array form. And after that, converted into the categorical form. Next, we define the dataset, split the dataset into train files and train targets. After that, print the number of total categories, total images, training images, and also test images. And in this part, each image is converted into RGB form. Once it is converted into RGB channel, it is converted into 3D tensor, then OD. And this part is required to display the graph using matplotlib. And this is the model. So this first layer we have use convolution 2D activation and max pooling. And in second layer we have used 64 layers, and first layer we have used 34 layers. And in Platinum, we have used three-dimensional into the one-dimensional conversion. And softmax is used for classifying purpose. Once classifying is done, use model.compile. This part is used for to input the accuracy. So in this, we have used learning rate 0.004 so that it model can get high accuracy. Once the compiling is done, use model.fit, train tensor and train targets. Run the model. About 50 till 50 iterations. The training process is continued. So in this each iteration will display the accuracy of so validation loss and validation accuracy. So this is the graph along x-axis above equals to 50 and on y-axis accuracy. So this is the loss graph. And this is the result of the characteristics graph. Accuracy parameters, sensitivity, precision, FN score, and also equal score. For testing code. So these are the libraries we use for to create the GI. Click on run model. So here you can see the login page of osteoporosis. Here you can enter username, password, click on login button. So here you can upload the image from the dataset button. Just like this. You can see deleted is osteoporosis. You can check for another image. So you can see deleted is osteoporosis. And check for normal one. Load the image. So you can see print is normal. Do another input from the normal.